Okay, all right. So let's start today's tutorial session. This is going to be 10th number session, and in this session we are going to solve problems based on the power distribution reconfiguration, and we will also see some problems based on the microgrids, and we will see some problems based on the distributed generations, like we are having many renewable resources, solar photovoltaic and wind energy storage, wind, uh, wind energy conversion systems and storage and some energy storage systems also. So let us start uh, by this first question. So the first problem is that sectionalizing switches used in power distribution networks are off, and the options are: A is normally closed switches, B is normally open switches, C is partially closed switches, D is partially open switches. So as we all know that sectionalizing switches and tie line switches are used in power distribution networks, and for this power distribution reconfiguration, we either close or open these switches to just gain the some objectives like minimization of power minimization of energy losses or enhancing the reliability of the power distribution networks. So this is the primary distribution networks in which having like this is the feeder one. You can say this is the feeder one, and this is the feeder two, and below one is the feeder three. So these are the circuit breakers, and along with that we can see that for this primary feeder, these are having connected many sectionalizing switches. Like this one is sectionalizing switches. So during normal conditions, these switches are normally closed. And if any fault happens in this, like in these the loads connected to these laterals, then it is opened so that it just not disturb the other loads. Did not disturb the other loads that are taking power from these feeders. So sorry, 1 minute. So during fault conditions, these switch to become open, and during normal condition, these are closed. So in this problem, we having asked that sectionalized in the power networks are off. So in during normal condition, it is of closed switches. So the A option is correct. And uh, now we will see the next problem. The next problem is that tie line switches used in power distribution networks are off, and the options are same: normally closed switches, B option is normally open switches, C option is partially closed switches, D option is partially open switches. So again, if we see these figures, the tie switches are present between the different connecting between the different feeders. Like here, these are the tie switches. And for this power distribution reconfiguration problem, we just operate these, we just work on these sectionalizing switches and tie switches such that our objectives can be maintained. like enhancing reliability or minimizing the power losses in the network. So for this problem, the correct answer is normally open switches. Now if we see the differences, we can write like that: differences between the sectionalizing switches and tie line switches. Sectionalizing switches, during normal condition it is closed. So we can say that normally it is closed. And this tie line switches, normally it is open. And these switches be used in the fault condition. These switches are used in the fault condition such that the loads undisturbed, whatever unfaulty sections are. So in fault conditions, switch will be closed. And this tie line switch is used in the emergency or maintenance condition. Suppose this feeder 1 is unable to supply the power to this to their load areas, so we can take power from the other feeders also. So that's why it is here it is mentioned emergency or maintenance condition, or like feeder 1 having some maintenance is going on, so we can take the power from the other feeders. So in that condition it should be closed. Sorry, switch will be open, switch will be closed, and for sectionalizing switch it will be open. So based on this tie line and sectionalizing switches, we will see the next problem. The next problem is that when a fault occurs in distribution feeder, fault isolation and service restoration action depending on the fault location can be carried out by. So just try yourself. As I mentioned, this fault isolation, this sectionalizing switch should be opened. So this done by these sectionalizing switches, and service restoration means we have to close the tie line switches. So this will be done by the sectionalizing switch, and the service restoration done by the tie line switch. So the correct option for this third will be B, sectionalizing switches and tie line switches respectively. So if you face any problem in the solving these questions, then you can ask. Okay, Pedro is replying. For yes, for second number, it is B option is correct. So let us see the next problem. The next problem is that appropriate integration of a distributed generation unit to a distribution network reduces the energy loss of the network because A option is it provides renewable energy, B option is it supplies active power locally, C option is it mitigates power quality problems, and D option is it suppresses harmonics. Pedro, you can type your answer in the chat box. So integration of distributed generation unit to a distributed network reduces the power loss, energy loss of the network because yes, B is the correct option. So we all know that distributed generations are connected at the distribution side or at the customer inside. So it supplies the active power locally and so that we can reduce the power loss in the network. So for this problem, this B option is correct. The next question is that the following can be set as constant to maximize distributed generation penetration to distribution networks. I just to mention here that this is multiple select question. Multiple options can be correct. So type your answer in the chat box. The following can be set as constant to maximize distributed generation penetration to the distribution networks. A option is irregularity constant, B option is power balance constant, C option is thermal limit appliance, D option is all of these. D. Okay, good evening, Manish. Pedro has replied D. No, for this you have to think about radiality. Radiality constraint cannot be. It doesn't means DG penetration does not depend upon the topology of network. Whether it is radial or meshed, it doesn't matter. So this first A is incorrect. It cannot be set as a constant to maximize DG penetration. And this power balance constant and thermal limit of lines can be set as constant for any types of optimization problem. So these B and C are the correct option for this problem because the topology of the network is already fixed, either radial or meshed. And if you are maximizing the DG penetration, then you have to see on this power balance constant or thermal limit constant. So let us see the next problem. The next problem is that following objective function is formulated for distributed system planning problem, but not for distributed system reconfiguration problem. And this is also multiple select question. And in exam, whenever this multiple select question comes, then there is option written in this a square form. Another one is in like circular form. Means this is on for single choice question, and this is given means multiple select question. So just be careful during exam. Just like assignment. In assignment, this is similar followed. So type your answer in the chat box. Manish Pedro, you can give your answer in the chat box. And if you feel like that you have doubt, then you can ask me. So let me solve this problem. So this cost of new feeder routes or cost of substation expansion, these are the power system planning problem. While this minimizing the power loss or maximizing the reliability, this comes under the power distribution system reconfiguration problem. So for this problem number 6, A and B are correct option. These are like expansion problem, power system planning problem, and in this we categorize that we are we want to expand the power distribution system. So this A and B are the correct option, and these are like we are we are operating the switches in the power distribution network such that we can reduce the power loss or maximize the reliability for this distribution system reconfiguration problem. So C and D are the for distribution system reconfiguration problem, and A and B are for the power system planning problem. So these are for the these can be objective function for the C and D are for objective function for the distribution system reconfiguration problem. If you have doubt, either you can ask or you can type in the chat box also. I can, I will, I will try to solve your doubts. So next problem we are having, this problem is that which of the following attributes are relevant to define distributed generation? Options are: A option is types of distributed generation unit, B option is ratings of the distributed generation unit, C option is purpose of distributed generation, D option is locations of distributed generation. Manish is also left, so only one attendee is there, so you can try. Sorry, this problem is also having multiple choice. Multiple options can be correct. So this is also multiple select question. More than one choice can be correct. D. Okay, I have not replied. So if we see the definition of distributed generation according to this acronym, I have referred this. I referred this paper, distributed generation a definition. This is one is very nice paper for defining the DG. So basically, there are many ways to define distributed generations. If you see papers on based on that, but only relevant is that purpose and location. That purpose of DG is to provide a source of active electric power, and based on the location, we can say that the location of DG is defined as the installation and operation of electric power generation units connected directly to the distribution network or connected to the network on the customer side of the meter. So it is directly connected to distribution network or it is connected to network on the customer side of the meter. And for this purpose, it is provide a source of active electric power only. We don't supposed from the distributed generation that it supply reactive power also. So we just consider for the active electric power only. And if we see the other attributes like rating, ownership, types, environmental impacts, power, delivery, etc. These attributes are not relevant for defining DG. So for this problem, options C and D are correct. So if we see the purpose here, we are considering only the active electric power. So we can say that DG does not need to be able to provide reactive power. So these only are the correct options, purpose and location. And the other attributes we does not take care of that. So now come to the next problem, question number 8. This one is very simple problem. A generation unit is called distributed generation unit if it is located at A option is transmission network, B option is distribution network, C option is customer side of the meter, D option is extra high voltage network. Again, this is multiple select question. More than one choices can be correct. As I mentioned the location of distributed generation in the previous slide, so from there you can assume the what should be the correct answer for this problem 8. So in general, how can we define the distributed generation? So distributed generation can be defined as the electric power generation within a distribution networks or on the customer side of the networks. So from the distribution, we can, from the definition of DG, we can say that B and C are the correct option. Now let us see the next problem. Next problem is that connection point of grid connected DG is called, and the options are point of common connection, B option is point of connection, C option is point of common coupling, D option is point of coupling. So type your answer in the chat box. Yes. C is the correct option for this point of common coupling. We know that it's PCC. So Pedro, D is not the correct answer. C is the correct answer. So the connection point of grid connect DG is called the point of common coupling. It is also defined as the it is the point where ownership changes from utility to customer. So if you want to write, then you can also write in this way. PCC is the point. PCC is the point where the ownership. It's not a good way to say point. PCC is where the ownership changes from customer to utility. So in one side it is the ownership of utility, and in other side it is the ownership of customer. And uh, for this industrial type of customers, we generally take beyond this transformer, like at the high voltage side of the transformer, distribution transformer. And for the loads, for the our and for this residential type of load, we take it at the LV side of the transformer as the PCC point. So just take care of that thing. So today we are just going to solve all theoretical type of problems based on the power distribution reconfiguration, and based on distributed generation, and some problems based on the photovoltaic conversion system and this wind energy conversion system. So let us see the next problem. Next problem is that excessive high value of DG integration over and above the load demand of a distribution network causes. And the options are loss of generation, B option is over voltage in the network, C option is under voltage in the network, D option is high power losses. And again, this is multiple select question. More than one choices can be correct. So learners, you can type your answer in the chat box. What do you think that if we having excess DG penetration in the distribution network, what that will cause? So, first this if we are having high disintegration, then that will definitely cause over voltage in the network. So B option is going to be correct, and this over voltage also leads to the high current flowing in the network. So and that leads to also high power losses. So B and D are the correct options for this problem 10. So the next problem is that which of the flowing unit does not belong to renewable distributed generation? And the options are wind, B option is solar photovoltaic, and C option is small hydro, D option is gas turbine. Okay, B and D is yes, for this problem of 10, B and D are correct. Petro has given the correct answer for this problem. So now we are going to solve this 11 question 11. So in this question you have to tell that which unit does not belong to renewable distributed generation. So we all know that this wind and solar photovoltaic are renewable energy sources of energy, and this small hydro also comes under the renewable sources of energy. Only this gas turbine does not belong to renewable sources. So is non-renewable or non-conventional sources of energy. So one question comes in mind, why we have not taken this big hydro. So in some references you can see that big hydro does not comes under this renewable source of energy because it has also negative impact on our environment. So in some articles and in some references you can see that it uh, it taken as renewable source of energy, but on other hand this big hydro does not comes under this renewable source of energy. So that's why we have taken option as a small hydro. So the next problem, now we will see the next problem. So the next problem is that what does MPPT in photovoltaic stand for? And the options are A option is maximum power point tracking, B option is minimum power point tracking, C option is multiple power point tracking, D option is monolithic power point tracking. You can give your answer in the chat box. Eh, Okay, yes, very good. This is maximum power point tracking. So A is the correct option for this question 12. Maximum power point tracking. So what is the principle behind this MPPT? So the major principle of MPPT is to extract the maximum available power from PV module by making them operate at the most efficient voltage, or it is also called as peak power voltage, or it is also called peak power voltage or maximum power point voltage. So if we see this, just I want to little bit tell about this MPPT. So this is the IV curve, the red one, and blue one is the PV curve. So based we need to operate whatever the controller, whatever the converter we having. Like suppose we are having this solar panel. Suppose this is PV module. So the at the output of this PV module, suppose this is VPV, and let us take it a DC-DC converter plus control. And on the other side, we are having this battery or load. Battery, if it is charging purpose or load, we can say that. So what if we want to take the power, maximum power from the PV module, we just need to the maintain this voltage across the PV module at VMPP, VM maximum power voltage, or that peak power voltage. So we can say that if PVP is VMP, then PV will produce maximum power. There are many algorithms to implement this maximum power point tracking algorithm, like per turbine observe method, incremental conductance method. So in either way, we just implement this and we can extract the maximum power from the PV module. Otherwise, if you maintain this voltage PVV other than this VMP, then you are getting lesser than lesser power from the P lesser power from the PV module. So this is about for the maximum power point tracking. So now let us see the next problem. The next problem is that which of the following units are the major stakeholders in Indian mission of increasing share of renewable power generation? So this is also multiple select question. as we all know that approximately 30% of generation of total capacity, installed capacity in India are coming from the renewables, and out of which wind and solar photovoltaic are the major stakeholders. This contributes most among all the renewable energy sources. So for this problem, B and C are the correct. So for this problem number 13, wind and solar photovoltaic are the major stakeholders in Indian mission for of increasing share of renewable power generation. So now let us see the next problem. The next problem is that resulting feeders must meet the following conditions after distribution system reconfiguration. And the options are power in the distribution line will be same. B option is reliability of the network shall be maintained. C option is feeders meet all the load requirements. D option is none of these. Again, this is multiple select question. Multiple options can be correct. So after doing distribution system reconfiguration, you have to tell that what should be the condition shall be met before and after the configuration, after doing the configuration of distribution system. So type your answer in the chat box. Only one attendee is there, so no problem. What you feel you can. B and C. Very good. This is correct answer. Reliability of the network shall be maintained and feeder meet all the requirements. Yes. This is the basic principle of this distribution system reconfigurations, that after doing reconfiguration, reliability shall be maintained and also the feeders shall meet all the load requirements. So B and C are the correct options. And this power and distribution lines will be changed because after doing reconfiguration, the many switches that are in closed condition or open condition that may change later on open or closed depending upon the reconfiguration problem. So we can say that power in the distribution lines will be changed, not will be same. So I have written down here this about distribution system reconfigurations. We can see that under normal operating conditions, distribution engineers periodically reconfigure distribution feeders by opening or closing of switching operations in order to increase network reliability or reduce the line losses. In maximum optimization problem, we are having this only two objective functions, either to increase the network reliability or to reduce the line losses. Network increasing the network reliability means reducing the service interruption. So the resulting feeders and after doing reconfiguration, the resulting feeders must remain radial and meet all the load requirements. So these two conditions shall be met. So these definitions have been taken from this paper. Reconfiguration of electrical distribution networks for resistive line losses reduction. So let us see the next problem. Next problem is that which of the following is not an advantage of using renewable sources as sources of energy? And the options are A option is clean energy, B option is intermittent output, C option is less pollution, D option is reduction of carbon footprint. This is very simple problem. B. Yes, B is the correct option. Intermittent output means variable energy resources. It depends on the weather condition or climatic conditions. So we can say that intermittent output means variable energy resources. And these renewable sources are also called as non-dispatchable sources of energy. Means operators cannot control the power, that power coming from these sources of energy. So these are non-dispatchable sources of energy. And the examples are wind and solar photovoltaic. We can see that. And for dispatchable source of energy, we can control the power output according to our base or according to the power demand. And on the and if we see the advantages of this renewable source of energy, clean energy, of course, less pollution, reduction to carbon footprint. And this intermittent output is only is in the on this given option is the not advantage, this is disadvantage for this renewable sources of energy. So let us see the next problem. The next problem is that energy resources which are being used for many decades are known as. A option is conventional energy sources, B option is non-conventional energy sources, C option is primary energy sources, D option is fuel cells. So give your answer chat box. Yes, it is correct. So like thermal power plant, these are conventional energy sources which are being used for many decades. Or non-conventional energy sources are like renewable energy sources, PV, wind, that comes under this non-conventional energy sources. So A option is correct one. And the next problem is we are having a localized grouping of electricity generations, energy storages, and loads it termed as. Options are traditional grid, B option is microgrid, C option is virtual power plant, D option is microgrid. There is difference in micro and micro. Both are having different terms. So type your answer in the chat box. Yes, B is the correct option. So here some terms are new one, like this virtual power plant. This is also called as virtual power plant. So just we need to familiarize with these terms. So virtual power plant is the aggregation of all dispersed generation present in the power systems, and with the help of IoT or this control technology, IoT technology, just we are controlling all these dispersed energy sources plus these conventional sources of energy. So it is just rejuvenating the traditional power system into the modern power system. So that's why this term is coined. Virtual power plant is coined as. So this is the typical uh, figure for this denoting this virtual power plant. We are having home industries all are connected through this IoT technology, and this conventional power system is also there, and this power storage we are having EV storage battery. These fuel cells are also comes under this system, and other ones are like renewable resources, wind power, solar power, biomass, geothermal, hydropower. All these are all integration means if we see the difference between microgrid and virtual power plant is that microgrid is like localized in a just community level, in a just like at a small level, but virtual power plant means that it integration of all dispersed means that can be located at very far away and all are connected together this through this IoT technology, and that can be controlled through this communication or something advanced communication system. So I have also mentioned this definition of virtual power plant. So virtual power plant is remotely controlled scattered distributed energy sources with IoT devices to make them function as one power plant. And if we see this microgrid and virtual power plant difference, that it depends on hardware technology such as microgrid controllers, smart interverters, inverters, and switches to function. On the other hand, it depends primarily on the smart meters and on the information technology. And further, for microgrid, it consists of a fixed set of resources within a limited geographical location. As I mentioned, it is limited to a certain location. But on the other hand, it is like large geographical areas and aggregate them together. That combines to form a virtual power plant. So, virtual power plant combines a wide variety of resources in large geographic areas and aggregate them together. And the last option is microgrid. So, this one is you can say that traditional centralized power grid. That is, so the correct option for this problem 7 is microgrid. B option is correct. So let us see the next problem. Next problem we are having from the wind power system, wind energy. In this problem, which wind speed reaches a point where wind turbine is rotating at a dangerously high speed with the possibility of destruction due to centrifugal forces, then the wind turbine is furled and the generator is stopped. And the options are cut off wind speed, B option is rated wind speed, C option is cut in wind speed, D option is none of the above. What do you think? It is the maximum speed at which the wind turbine can produce power. Beyond this speed, wind turbine need to be stopped, otherwise it will get damaged. So you can give your answer in chat box. Options are cut off wind speed. This is the second last problem. So we are having left one more question. So the options are cut off wind speed, B option is rated wind speed, C option is cut in wind speed, D option is none of the above. You have to tell the speed beyond which the wind turbine need to be stopped, otherwise it will get damaged. So what is the term called as? Pedro, you can type your answer in chat box. So we know that there are three terms related to this wind energy: cut-in wind speed, rated wind speed, and cut-out wind speeds. So cut-out wind speed are also called as cut-off wind speed or shutdown speed or furling speed. So cut-in wind speed is that speed at which the turbine starts to operate and deliver power. So below which the turbine unable to produce power. So this is the minimum speed at which the turbine can deliver power, and the maximum speed at which turbine can deliver power is the cutout wind speed, and beyond which it cannot operate, it will get damaged. So we have to just need to provide protection system so that it just unfold itself, or some other mechanism, by other mechanism it we can reduce the speed and take the power from the wind turbine. And the rated wind speed, the speed at which the system produces nominal power, which is also called the rated output power of generator. And generally we use the generator, permanent magnet synchronous generator, and doubly fed induction generator in this wind energy conversion system. So these are widely used generators for this, for integrating this wind energy. PMSG stand for permanent magnet synchronous generator, and this DFIG stands for doubly fed induction generator. And the third one is that cutout wind speed is that wind speed at which turbine is allowed to operate before it shut down. So beyond which it will not operate. So the correct option for this problem number 18 is that cutoff wind speed. So now let us see the last problem of today's session. So the last problem is that the blades in wind turbines are connected to. Options are string, B option is tower, C option is foundations, D option is Nestle. So I have just put one figure for your better understanding. So this is the figure for wind turbines, and we can see that this is the rotor blade which is connected to the Nestle. This is whole, this round type shape that connected to the rotor blade is called Nestle. That contains gearbox, generator, all comes under this Nestle part. Generator brake all comes under this Nestle part. So the correct option for this part is Nestle. D option is correct. So we see this whole part is called Nestle. And this contains gearbox, generator brake, all comes under this Nestle only. And this is the tower, and towers can be of many types, like depending upon the materials used or the strength of the material, like tubular steel tower, lattice tower, concrete tower, or guide tubular tower. And and this below one is the foundations can be also many times depending upon the capacity and the depending upon the capacity of tower and the structure of the tower. Like we are having two commonly foundation, which are a spread foundation or piled foundation. So So that's all about today's session. If you are having any doubt, you can ask. Otherwise, we can close our session today. Pedro, do you have any doubt? Pedro, do you hear me? I think he's not here. So thank you for joining, Pedro, and we will meet on the next Saturday for the session number 11. Thank you all.